This is the beginning of circuits and current electricity. I'm going to be introducing Ohm's law. Voltage equals current, I, times resistance, R. We're going to be introducing power equation. Power is current times voltage. Oops. And we're going to be introducing energy is equal to power times time. Current is the rate of charge flow. It is measured in the unit called the ampere, which is 1 coulomb per second. Voltage, abbreviated V, measured in volts, is the electric potential difference. It's essentially what drives the current through the circuit. Power, just like in your previous units, is measured in watts, is 1 joule per second. It's the rate at which work is done. And resistance, which is a new concept we looked at briefly with resistivity. Resistance, which is measured in ohms, abbreviated with the capital Greek letter omega, is the ratio of voltage to current. Resistance is the opposition to the current that is flowing through the wire. It is how difficult it is for the current to pass through the wire. Energy is just going to be power times time, which is consistent with previous units. So we have the equations that you're going to need to know here. And we'll be using them in some sample problems below. So we're going to first find the power consumed by a motor powered by a 6-volt battery delivering half an amp of current. So power is what we're looking for. We have 6 volts and our current is 0.5 amps. So you can see we're going to use the power equation. P is equal to IV. And we're just going to plug it in. 0.5 amps times 6 volts. And when you multiply 0.5 times 6, you're going to get the 3 watts, which is, of course, the answer. Part A, find the amount of energy delivered in 5 minutes. 5 minutes is 300 seconds. So when we go back to our equation, energy is power times time. It's going to be the 3 watts, which we calculated in part 1, times the 300 seconds, which is going to be 900 joules of power. Problem 2. Find the power consumed by a light bulb connected to a 120 volt outlet delivering 0.5 amps of current. So go ahead and write down the givens and restart the video once you have identified them. So our givens here were the 120 volts and the 0.5 amps of current, and we're trying to find power. Power was question mark, voltage was 120 volts, and I was equal to 0.5 amps of current. So we could plug this into the power equation. P equals IV. 0.5 amps times 120 volts is going to give you 60 watts. Problem 3. Find the power consumed by a car's headlight powered by a 12-volt battery delivering 2 amps of current. So power is what we're looking for. Voltage is 12 volts. Current is 2 amps. So, again, this should just be a simple application of the power equation. P equals IV. So it's going to be the 2 amps times the 12 volts. It's going to give you 24 watts. Problem 4. Find the current flowing through a 75 watt light bulb connected to a 120 volt power supply. So we know our power is a given, 75 watts. And we know we're looking for our current, that's our unknown. And we know our voltage is 120 volts. So we're going to write our power equation. This time we're solving for I. So we're going to divide both sides by V. So we have 75 over 120. That's the 75 watts over the 120 volts. Go ahead and divide that in your calculator. And you're going to get 0.625 amps. So that answer there was slightly rounded. Find the current flowing through a 10 ohm resistor powered by a 30 volt battery. So write down our givens. I is what we're looking for. R is 10 ohms. And voltage is 30 volts. That looks like an application of Ohm's law. V is equal to IR, Ohm's law. And we're looking for I, which is V over R. We divide both sides by R. And so we're going to get 30 volts divided by our resistance of 10 ohms. 30 volts over 10 ohms is going to reduce to a current of 3, and the unit is the ampere. Okay, so we have now completed this page and introduced you to the power equation and Ohm's law. Let us continue a few additional practice problems on the next page. So we need to find the current when 12 volts is dropped across a 30 ohm resistor. So we're looking for current. Our voltage is 12 and our resistance is 30. If you know how to do the problem, why don't you go ahead and pause the video and do it, and then check back that you did it correctly. So Ohm's law, V equals IR. Current is equal to voltage divided by resistance. So we're going to do the 12 volts divided by our 30 ohms. And we're going to get 0.4 amps. Problem 7. Find the voltage source delivering 3.8 amps to a motor with an operating resistance of 32 ohms. So we need the voltage. So voltage is question mark. Current is 3.8. And R is 32 ohms. Ohm's law, V equals IR. We get 3.8 amps times our 32 ohms. So again, I multiply that out on your calculator. And when you do that, you should get 121.6 volts. Okay, let's take a look at problem 8. Find the resistance of a radio operated by a 3-volt battery consuming 2 times 10 to the negative 4th amperes of current. So, resistance is what we're finding. Our voltage is 3 volts. But our current I, remember that's scientific notation, so it's 0.1230 followed by a 2, and that's 1, 2 times 10 to the negative 4th. So V equals IR, Ohm's law, because we have current, voltage, and resistance in this problem. We're solving for R, which is voltage over current. So you have your 3 volts, and you're going to divide by 0.0002 amps of current. And if you type that into your calculator, 3 divided by, you do get 15,000 ohms. Okay. Why don't you go ahead and read number 9 and try and identify the givens. Pause the video, and you can restart the video once you have found them. So, number 9, hopefully you recognize, is a 2-part problem. You have resistance and power. The givens are current and voltage. So let's start with the givens. Current is 0.5 amps. Our voltage is 120 volts. And we'll start in the beginning. We're looking for resistance. So that's simply Ohm's law, V equals IR. And we're looking for R, V over I, 120 volts divided by 0.5 amps. So that's going to be 240 ohms. Second part, they're looking for power. So if we're looking for power and we have current and resistance, we're going to use the power equation. Power is current times voltage. And our current was 0.5 amps. Our voltage was 120 volts. And that's going to be 60 watts. Problem 10. Find current and resistance. Again, a 2-part problem of a 75 watt light bulb connects to a 120 volt power supply. So, I know our power is 75, and our voltage is 120, and I is what we're looking for. P is equal to IV, power equation. I is equal to power divided by voltage, which is just going to be your 75 watts divided by your 120 volts. So go ahead and type that in your calculator. And you do get 0.625 amps. Second part of that is finding the resistance. So V equals IR. We're looking for resistance is V over I. So V is 120. I we just found to be 0.625. So we divide that. We do get 192 ohms. Okay, 192. Clean that up a little. Question 11. A 15 ohm electric heater is powered by 120 volts. So we are given our resistance, 15 ohms, and our voltage is 120. We have to find the current. So I is equal to V divided by R. When we solve Ohm's law, we get 120 volts divided by 15 ohms of current. So let's type that into our calculator. And we get 8 amps of current for our answer. All right, find the amount of power the heater is using. So we know voltage, we know resistance, and in part A we found current. So we should be able to use the power equation. So our current is 8 amps, and our voltage was 120 volts. So go ahead and multiply that in your calculator, 8 times 120, and you get 960. And the last problem, find the amount of energy used in 30 seconds. So energy is equal power times time. In part B, we found power to be 960 watts, and our time was 30 seconds. So what do we get when we do 960 times 30? We get 28,800 joules. So that's the amount of energy, 28,800 joules. So that concludes the introduction to Ohm's law, the power equation, and energy is equal to power times time.